7-1 was graphing and substitution. I'm going to do one of each for this just so we can get the practice of the setup. So for the first one, if I did substitution, it's easier to get the y by itself. So I could have done negative y equals 14 minus 6x and then multiply everything by negative 1. So y would equal negative 14 plus 6x. Then I take that and I plug it into the y of the other one. So 2x plus 3 times negative 14 plus 6x equals 18. Distribute the 3 plus 18. Combine your like terms here. So 20x, add this, would equal 60, and x would be 3. So that's the first one. And then I want to take and plug that back in. I can plug it back into either original, or I can plug it back into the one I solved for y. And it's already got the y isolated, so y would equal negative 14 plus 18, which is 4. Oh, it's... So if I went to 2, I probably would have done substitution again, but let's just practice the graphing since we're on it. I would solve for y, so I'd get 2y equals negative 5x minus 1 divided by 2. Y would equal negative 5 halves x minus 1 half, and then I would bring in a coordinate grid. Negative 1 half, and down 5, 1, 2, 3, 4, 5 to the right 2. Or up 1, 2, 3, 4, 5, and left 2. Okay, then the second one, solve this for y, and I'd get 3y equals negative x plus 5, divide both sides by 3. So if I had the choice, I definitely wouldn't have done graphing on this, especially because they are fractions, right? 1 and 2/3 is my y-intercept. And then down 1 and to the right 3, or up 1 and to the left 3. And they're going to cross, and it looks like they cross right here at negative 1, 2. If you had done substitution, you should get the same answer. So if you have the choice and your graph ends up with fractions, I would say pick something else. Pick substitution. The only time you're going to want one is you'll be forced to. Like it will tell you have to do graphing. Or when they're nice, obvious whole numbers that you can plot easier. All right, then the word problem says you're given the yearly interest earned from a total of $25,000 invested in 2 funds paying the given rates of simple interest. Write and solve the systems of equation to find the amount invested in each rate. So I've got my x, which would be rate 1, and my y, which is rate 2. The total investment is $25,000, so x plus y equals $25,000. And then the interest earned on them is 0.02 for the x, 0.04 for the y. So if I wanted to set up a system, I have the first equation already there. The other one would be 0.02x plus 0.04y equals 730. Now to get rid of the decimal, I'd multiply everything here by 100. Moves the digit twice. So 2x plus 4y equals, and it would tack on 2 zeros there. Don't forget to go all the way to the other side of the equal sign. That's probably the biggest mistake people make with this stuff. And then I end up with this system. I would say, again, we're practicing substitution or graphing. I would have picked substitution here. X would equal 25,000 minus y. Take that, plug it back in. So 2 times 25,000 minus y plus 4y equals 730. No. Yeah. Okay. Wait. Yeah, that's the right one. Is yours. Then distribute here. So 50,000 minus 2y plus 4y equals 73,000. 50,000 plus 2y would equal 73,000. Subtract the 50. 2y would equal 23,000, and then divide both sides by 2. That's your y. And then it says in each rate, so that's the y is your $11,500 at 4%. And then I would do 25,000 minus that. $13,500 at the 2%, which would have been the x.
You did 23,000 divided by 2.
Yeah.
What did that give you?
11,500.
So that's your y, and then you plug it in.
Right. Yep.
Is that required?
No, just know which one's which. So like if it had only asked you for the 2%, you got to know which one's which.
Okay, so on the test I wouldn't have to say 11,500 at 4%.
You would have to, yeah, you're going to tell me which one's which.
Oh.
You mean like the physical at symbol or that which one's which? You do have to identify which one's which.
Okay.
Yeah. Or if it only asks for one, then you got to give that one. Yeah.
Is this most likely going to be one of our, is this like our only one problem from 7.1?
No.
Like, because the ones on the side, like, we're going to get ones like those.
You're going to get systems, yeah. So I'll do a couple. This one is 13. It says a small software company invests $16,000 to produce a software package that will sell for $51.95. Each can be produced for $9.45. Write the cost and revenue functions for X, and then you're finding and then using the graph utility to graph both of those, and then approximate the number of units that have to be sold to break even. So when you're setting it up, this time I didn't give you the cost function and the revenue function. You had to come up with it. So everything that costs, obviously, is your cost-related information. So if you're investing $16,000, it's an initial cost. That's part of your cost function. And then if it sells for, that's your revenue. So the revenue is $51.95 per unit. So it's 51.95x. The cost is your initial upfront fee, that's $16,000, plus how much it costs to produce each one, which is $9.45 per unit. So that gets the x. So this is my cost function, that's my revenue function, and the break even happens when they are equal to each other. So I would set this equal.
Wait, the top one is the cost function?
Yep. Here, let me write it on the second line. So 51.95x equals 16,000 plus 9.45x. And then I would subtract.
Where'd you get the 51?
It said that's how much it cost to, or that's how much they were going to sell them for. So this is something. You're trying to figure out how much they'd need. Yeah, that's what it says. Approximate the number of units that you would need to break even. So the break even is when they're equal.
They asked us a question like approximate the profit, what unit would they
Sure. So like number of units would be X, plug it back in, and that's your revenue or your cost. You can plug it back in either one, just like we do with the other stuff. Okay, so what I subtract there, 42.5x equals 16,000, and then divide both sides by the 42.5. 16,000 divided by 42.5. And it said 376 units. So it actually said round your answer to the nearest unit. Normally on a break even, we round that up. So normally on the break even, because this is be 0.4, it actually would be 0.5. It would need to be rounded up. So this one, the wording said approximate the number of units to be sold to break even. I actually think a better answer here is 377 because you have to. Otherwise, if you round down on this, if you round to, 47. If you round down on this to 376, you don't break even yet. So I would want you to round up. If you go off the graph, that's kind of what it was telling you to do. I would set each of these, I would make the C and the R would be the Y here. And I would literally just plug those equations in and look for where they cross, which was here. And the X value there was that 376. The 11 said use the graphing utility to graph the cost and the revenue in the same window and then find the sales necessary. So we're doing the same thing. We would do Y equals here. So Y equals 2.05x.
Wait, so that was the answer for the other one?
Yep.
You don't have to plug it back in, right?
It didn't want the cost or the revenue, it just wanted the amount of units. 4.58x. Oh, I should do this on the... Okay, so I graphed it on the app because it's easier to zoom in and out on that because we have to zoom out a lot. The question here says, find the sales X necessary to break even where R equals C, and then the corresponding R. So it wanted both parts. The break even is the X value here. So 160,714. And then take that, plug it in, and that's what the Y is, which is the 779,464. So as far as like a question on a quiz or a test with this stuff, you would not have to use the graphing utility. You would just set it equal to each other and solve for X, which is like what the example that we did on the notes. It would be like that. You probably will not have your graphing utility on this kind of a question. Okay, we're gonna do this one and then we're gonna switch gears. So this says you're offered 2 jobs selling college textbooks. One company offers an annual salary of $37,000 plus a year-end bonus of 1% of your sales, and the other company offers $34,000 plus a year-end of 2% of your total sales. What's the minimum you'd have to sell in the year to make the second offer better? So I basically want to know if I've got the first, like first job, the second one. They're both based on the sales, right? So X could be your sales. This is 37,000 plus 1% of the sales, or 37,000 plus 0.01x. The second job is 34,000 plus 2% of your sales, so 34,000 plus 0.02x. So you're trying to figure out which would make the second offer better. If we set these equal to each other and solve, so you can get rid of the decimal if you want or not, it's up to you. If I want to, I'd have to do 100, so 37, I'd add on 2 zeros plus 1x equals 34, add on the 2 zeros plus 2x, subtract the x. And then subtract the 34. God bless you. Sure. God bless you.
Thank you.
So that's the point in which they would be equal to each other. Anything more than that, and the right side's going to be a better option. So this was a nice rounded whole number, but you would have just divided. Mm-hmm. All right, so 7.2 is systems of equations, but this is using the third method, which is elimination. Sometimes it's called addition, sometimes it's elimination, like they call those different things. But basically, this is the third method we're going to use to solve a system. In my opinion, it's probably the most popular. It's the one people choose the most if you had the choice. Here's your steps. So the goal is to get both equations into standard form, mostly just lining up the x's and the y's. Like it doesn't have to be in that order, but the x's need to be in the same row, column as the y's in both equations. If needed, change one or both of the equations so that when you combine these equations, one of the variables cancels out. Then you're going to combine the equations. So what should be left is just one variable. You're going to solve for that variable, and then you're going to plug it back into either of the original equations to solve for the second variable. There are special cases like this, just like with the other ones. If both variables cancel out and the statement is false, then it's no solution. If it's true, then it's all real numbers. On WebAssign, I think it says infinitely many if it's all real numbers, but it'll give you the words to actually put it on there. The other thing that WebAssign will ask is consistent and inconsistent. Inconsistent would be like no solution. And consistent means it has a solution. So if you can solve for the x and y, then it's consistent. All right, so they could look like this. Notice it says solve using elimination. Remember I said sometimes you're going to get given which method to use and you need to follow that method, and then sometimes it's just going to say solve and you get to pick, okay? But we're going to practice the elimination for this one. So if I look at there in line, right, I have the x's lined up, the y's lined up, and then the constant on the other side of the equal sign. If I add these as they are, do one of the variables cancel out? If I add them, I'd get 3x, right, plus 2y. That does not cancel out. So I have to change one of these equations so that one of the variables cancel out. And it doesn't matter which one. I would say tend to look for things that already are opposite signs if that's an option, because God knows you guys make silly mistakes when it comes to those positive negatives, right? So if I look at the y's, they're already opposite sign. I could just multiply the bottom row by what to cancel out the y? 3. So to multiply everything in that equation by 3. And then I'm going to add it to the original first equation. If you've done it correctly, then one of the variables should cancel out. So that y is going to cancel here.
Doesn't matter which one goes on top of that one.
Nope. And then we divide both sides by 5, and I get x is 8.
Wait, do you add?
Yep.
You can also multiply by negative.
Sure.
But when you add, you don't change anything.
You just straight up add. Yep. And then I'm going to take this and plug it back in, and I could plug it back into either of the original equations. I could even plug it back into the one I multiplied by 3, but those are bigger numbers, so I'd probably avoid it. So I'm going to plug it into the second one. 8 minus y equals 9. Negative y would equal 1, and y would equal negative 1. So the answer to this is 8, negative 1. Okay, same set of instructions, solve using elimination. So looking at A, if I add them, does something cancel? Yes, I don't even have to change anything here. Add them, I get 2y, the x's cancel, equals 30. Divide both sides by 2, y is 15. Take and plug it back into either of the original equations. So if I plug it back into here, 15 plus x equals 20. Subtract the 15, and x is 5. Careful with your order, make sure it's x and then y. Okay, now look at B. If I add them, do they cancel? Can I change just one? No, this is a situation in which I got to change both. So what's one option? Top by 5, bottom by 2. That's an option. What about if I want to get rid of the x's? Could I do that? Good. Top by 2, bottom by... one of those would have to be negative, right? Either the negative 2 or the negative 3. It doesn't matter. Because the y's are already opposite sign, I would say probably I would recommend you do that instead. But it's totally up to you. So I'm going to multiply this by 5 and this by 2. So I get 15x plus 10y equals 20. Don't forget to go to the other side of the equal sign. And then 4x minus 10y equals negative 58. Combine your equations. So add them. 19x. These cancel. Negative 38. Divide both sides by 19. And x equals negative 2. Take and plug it back in. It can go anywhere. So if you want to go to the top one, 3 times negative 2 plus 2y equals 4. Negative 6 plus 2y equals 4. Add the 6. 2y equals 10, and y equals 5. All right, so this says use any method to solve the system. And this is exactly what I'm talking about. If I just look at this and I add them, the y's cancel. So this is not one of those that I would like solve for substitution, you can. I can move the 5y in the top, but I also can just add these, and I get 7x, these cancel, equals 42. Divide both sides by 7, and x is 6. Take and plug that back in, so I'm going to plug it back into the top. 6 minus 5y equals 21. Subtract the 6. Positive 15. Divide by negative 5. 6, negative 3 is my solution. Still good? All right. Now you get some application. So in this section, you get something called equilibrium point. This is very similar to break even, okay? It says find the equilibrium point of the demand and the supply of the demand and supply equations. So I give you the demand and supply equations, right? Your variables here are P, which is the price, and X, which is the number of units. So the difference with equilibrium point is you want both the X and P. So we're not just finding the number of units, we're finding the number of units and then finding the price that we should sell them at. So you're looking for both things. So in this example, I would say this is set up easier for substitution. If P equals 500 minus 0.4x, and then the other side, P equals 380 plus 0.1x, I could literally take this, plug it in, and just set these equal to each other. If you wanted to do elimination, you could do that too. You just got to line them up. So from here, I would add the 0.4x. 380 plus 0.5x equals 500. Subtract the 380. 0.5x equals 120. And then 120 divided by 0.5 is 240. I could have totally gotten rid of the decimals. Like if you wanted to get rid of them from here, you can multiply everything by 10 to move the decimals over. You'll still be solving at the end for x.
So do we just plug it into whatever?
So now you want the p, and you can plug it back into either of them. Yep. So the number of units is 240. But we also want to know the price per unit. So we take and plug it back in. I would say 0.1 is easier because you only have to move the decimal once, but you could do either. So this would be 380 plus 24, or 404. And that's your price per unit. So it does not go in coordinate point form anymore. You're actually using this like to answer the question, how many units and how much per unit.
But like, how would you say the answer is?
It would be, so like on WebAssign, it might even give you like a little space, like so ever many units at price per unit. If it was like a quiz or test, you would literally just give me both those things. Like,
And label X and P.
it doesn't even have to be X and P as long as you say how many units. Like 204 units tells me that is X. And then the price per unit is the P. Questions on that one? All right, then you got another word problem. So this one says, a minor league baseball team had a total attendance one evening of 1,175. The tickets for the adult and children sold for $5 and $3.50 respectively. The ticket revenue that night was $5,087.50. Create a system of linear equations to find the number of adults A and children C at the game. Solve your system of equation by elimination or substitution, and then use your graphing utility to verify. So it gave you specific variables like A and C for children and adult. You could have made them X and Y as long as you know which one's which, okay? The benefit of A and C is you know when you solve A is my adult. I don't have to figure out what X and Y was, right? So what's information that they give me that can help me set up an equation?
How many tickets they sold?
How many tickets they sold total. So what would that look like in equation form?
X plus Y equals 1,175.
Good. So we'll do A and C, but you could do X and Y. A plus C equals 1,175. That's one of my two equations.
And then 5,087.5
$5 a.
Good. Each adult ticket was $5. Each child ticket, 3.5. You could put 3.50, but you don't need the 0. All right, now I have a system and you have choices. You could either do elimination or you could do substitution. Out of curiosity, how many of you would choose elimination? How many would choose substitution? Interesting. Okay, so let's say we're going to do substitution. We can solve for either A and C. It doesn't matter because they want to know both. If it had specifically said how many adult tickets were sold, I would want to make sure that I solve for C and then plug in so A is still part of my equation. Then you don't have to do both, okay? But this is asking for both. So I would say 1175 minus C equals A. That's my substitution. Take this and plug it in for A. So 5 times 1175 minus C plus 3.5C equals 5,087.50 cents. Distribute here. So 5 times 1175 is 5,875 minus 5C plus 3.5C equals 5,087.5. Combine my like terms here. 50. This would be 1.5. Subtract. And then divide.
That y could never be -10
Correct.
for like this specific problem.
Yeah.
It can't be negative.
No, you can't sell a negative amount of, right? Yeah. So this says C, so this is children's tickets was 525. How would I find A? Plug it back in. So I can either plug it back in here, or the one we've already isolated for A. So 1175 minus that 525. And there's my 650. So that's how many was sold at the, or how many adult tickets were sold. So when it asks solve the system, it's 650 adult tickets and 525 children's tickets. And then it says to use the graphing utility to verify. So to solve for the graphing utility, you'd have to take your equations and solve for either variable. It doesn't matter which one. But let's say we make the A what we want to solve for. A would equal 1,175 minus C. And for the second one, I would get 5A plus 3.5C equals 50. I'd have to subtract. It doesn't matter.
It'll still give you the.
5A would equal 5,000 minus 3.5C, and then divide everything by 5. And I would type that into my calculator. So Y equals, the first one was 1175 minus C, which could be X. And then group together your numerator, 5,087.5 minus 3.5X, close the parentheses, divided by 5. I should have done it on the app because it's going to be easier to zoom out. But all right, so it said to verify using your graphing utility. So we obviously did the work first. And then if I graph it on the graphing utility, you see X is 525 and Y would be 650. So that's the, your way to check your answers on that system. And it matches what we found, 650 adult and 525 children.
That's good.
Yeah.
So that like work that you did at the bottom is leaving it as like a.
This was just putting it in terms of, so getting into slope intercept. Correct. Questions? All right, there is a question on WebAssign dealing with airspeed. So this is number 8. If you want to go screenshot it so you can I can help you start to set it up. There's a couple word problems in there, but this one says something about an airplane flying into a headwind, okay? So there's headwind and there's tailwind. Headwind is something coming up against the plane, which slows it down. Tailwind would be something that's pushing it, which makes it faster. Okay, so those are your variables here. It says travels 1,800 mile flying distance between New York and Albuquerque, New Mexico for 3 hours and 45 minutes, the one with headwind. And then on the return flight, the same distance is traveled 3 hours and 36 minutes. Find the airspeed of the plane and the speed of the wind. So when you have headwind, it is slowing you down, okay? So if distance equals rate times time, my distance is 1,800 for both. They're both going the same distance. Then it says from New York, from New York to New Mexico, it's 3 hours and 45 minutes. So first of all, I have to take that 45 minutes and convert that into an hour. So 45 over 60 is what? When you reduce it? 3/4. So that would be 0.75. So the time there is 3.75 hours.
So if it was 3 hours, you do 60.
If it was 3 hours, say again?
If it was 3 hours, you do 60 plus 30, like 60 divided by.
I do 45 divided by 60 to get the decimal part there. I'm trying to convert minutes into hours, right? So 45 minutes is 0.75 hours.
So you do all of them.
Mm-hmm. Yep. So I'm going to do the same thing for 3 hours and 36 minutes. If I did 36 divided by 60, it's 0.6. So that time is 3.6. If the airspeed, again, so the headwind is slowing them down, which means this rate minus, and you could make it wind. You can make whatever variable you want there, but something is slowing it down. So it could be wind. It actually says the word airspeed. So if you wanted to make it speed, you could do that. Doesn't matter. That's going to get multiplied by the time that we just found. And then on the way back, it's going faster. So your rate plus your speed is happening there. So again, I could make them W for wind. You can make it S for airspeed. It doesn't matter what you make it, okay? But on the slower one, you're taking that away because it's slowing it down. So it's R minus S. And on the faster one, you're adding it. So it's R plus S.
What's R then?
R is the rate.
Which is the,
We don't know it.
oh, no.
That's what you don't know. Those are your variables. R and S are your variables. T we know. So this is 1,800 equals 3.75 times R minus S. And then this is 1,800 equals 3.6 times R plus S.
You put
R
R minus.
minus S is the one that's slower, right? The headwind. It takes it longer to travel, so it should make sense that it's slower. And then the other one is faster. Bye, guys. Have a great day.